Steve came to me back in the summer and asked me if I would put together a presentation basically detailing some of the common herbicide symptomology that you guys may or may not find out there on the landscape dealing with that type of herbicide work that's done on a normal basis out there, and looking at that symptomology and trying to diagnose what you're actually looking at, and then what potential corrective action. In my experience, when you go out and you talk with a landowner, you talk with someone that owns something that was accidentally or on purpose sprayed with different types of herbicide, usually the question is, what happened? I mean, why are my trees looking like that? What's going on in this world? Why do I look like I'm losing my trees? And when it comes down to the fact that it was probably a herbicide and not something that's just a natural occurrence out there in nature, the next question that always comes out is it going to kill my tree? And then after that, it's, well, what can I do if it isn't? So what I want to do is kind of go through some of those steps and some of the symptomology and let you guys have an idea of some of the things that you might want to look at from that aspect. When you go out and you see something like that, and yes, it does happen, that one's pretty much a gimme. You know that tree is not coming back. You may not know what necessarily hit it, but you know it's gone. It's all those other little intermediate symptoms that you look at out there, for everything from cupping to just some chlorosis, some necrosis, epinasty, all the different things that can go on out there, and being able to help determine what caused those. Is it actually a herbicide, or is it something that is natural, like a fungal infestation or drought effects or something like that? And being able to identify through different observations that you can do out there in the field, and come up with an idea of what actually touched that tree to do the damage that you're looking at. There's several ways that you can do different types of analyses to determine what type of herbicide you're looking at. There are some vegetative and some soil analyses that can be performed. They're usually pretty costly, and I'm going to throw up a few cost and panel analysis pictures here in just a second. But if you'll contact Mississippi State Chemical Laboratory, which is in Starkville on the MSU campus, you'll find a form. You can find it online, or you can find it, just call and they'll give you a link to that form. You fill out that form, use the proper collection techniques, and request the certain type of test that you want. And when I say the fact that they're costly, that depends on your idea of costly. That's fair. But most people start balking when they look at the cost, and they look at the fact that they may have to run multiple tests if they don't know exactly what was put out there. Now, again, this is a diagnostic type of event if you're doing this from observational symptomology. But when you are sending something into the chem lab, there are some panel tests. If you'll look there at the proportion of that sheet, that's the phenoxy herbicides. So, the growth regulators, 2,4-D, dicamba, triclopyr, things like that are going to give you that cupping, that epinastic response that we'll go through here in a little while on tree, primarily tree foliage, but you can get that type of effect also on some of the young growth, the twig type structures. They do have panel tests that will detect a lot of those for, in this case, $200. Or if you know for sure what it is and you're needing to, for litigation purposes or something like that, what herbicide was applied, you can actually send in a tissue or a soil sample, and they can test for that single herbicide for $125 a sample. The problem with that is in this type of work, you don't necessarily know what was applied, right? It's kind of rare to know that somebody did spray dicamba on that field. It drifted over onto those yard trees that you're being called out to look at. When it gets into that type of situation, things change. There are lots of different panels, and some of these will capture the different types of herbicides. And then when you really get into the nitpicky, some of those are not listed in those panels. And you have to test for them individually. So you go out and you see a tree that has epinastic growth, chlorosis, necrosis, terminal buds are popped off the ends of the branches, and you have no idea what happened. There's a few different herbicides that will fit into the realm of that type of damage. The problem with it is there are different families of herbicides. When you get into different families of herbicides, your cost goes up dramatically. They can't test for all of those herbicides for one cost. When you get into that world, you start seeing these individual herbicides listed out, and the costs go up dramatically. Different costs for different things. One of the things that I did think was interesting, and I actually called over to the chem lab to talk with them the other day to see exactly the reasoning behind the different price lists. You'll look down at the bottom, individual pesticide analysis price list there. You'll see like paraquat and diquat, not going to be used in the lawns unless it's, it's a drift issue usually. What you'll see there is a $200 versus some of the other more common herbicides as you move down the list at $125 sample. That cost differential boils down to the fact that in this case, paraquat is a lot harder to lift out of that damaged tissue. So it's a more involved process for them to be able to extract that compound from the tissue and be able to tell you what it was. Now, I asked, the next question I had was, well, what about herbicides that I don't see on there? And the one that pops into my mind from forestry is imazapyr. And the lady that I talked with, this is a quote, she said, well, you can't put 9,000 different compounds on a price sheet. And she's right. She said, anything that you want tested, so long as you have an idea of what it was, they can probably test it. And they will work with you on pricing. Regardless, a lot of this is one at a time, and a lot of it's going to cost you a lot of money. And that really leaves observations of actual physical herbicide symptomology in the field as the next best. I will say it's scientifically based, but a lot of it is your best guess when you're out there on the ground and trying to identify the type of symptomological impact from those herbicides. So that's your next best step. And in that case, you're looking at the physiological indicators. You're looking at the symptomological indicators like necrosis, chlorosis, witch's broom, things like that. And then also the effects of whatever was applied on surrounding vegetation. What did it do to the grass under the tree? What did it do to other species of trees? What did it do to the broadleafs at the side of the yard? That kind of thing. And what you're doing is you're trying to, process of elimination, take things away from the table that it is not. And there's a lot of different herbicides and a lot of different things that happen out there on the ground. So the next series of photos and slides that I'm going to run through here are really different groups of herbicides, basically different modes of action and how those herbicides appear, how they actually impact foliage primarily, but you also get some root impacts, you get some twig impacts and things like that. But how those different herbicides affect different species of trees and different things to look at, different symptoms to be able to start whittling down that list of possibilities that are out there. The first herbicides that I want to talk about are growth regulators. That's going to be the hormonal herbicides. You hear these called phenoxy herbicides, synthetic auxin herbicides, and basically they'll cause the cupping. If you look there at the oak on the right, they'll cause that cupping effect. They'll basically make plant tissues go out of whack, for lack of better term. They'll grow in abnormal ways. That's going to be the things like 2,4-D, dicamba, triclopyr, clopyralid, picloram, a lot of those different herbicides there. And a lot of those are going to be used in different lawn herbicides, especially some of the pre-emergent type herbicides are going to fall into this group, like dicamba before they took it off the market. And a lot of those herbicides can be applied underneath most trees, so long as you stay inside labeled rates, you don't have a problem. It's when you do things that you're not supposed to do, or when you put different herbicides in lawn settings that aren't necessarily labeled for lawn settings. And I'll talk a little bit more in depth about that as we go. So a lot of that, so long as you're on the right side of the labeled rate, you're okay, so long as it's labeled for where you're putting it and you apply it in the proper manner. So a lot of it does depend on not only on the level of exposure. So if you're putting 2 times the rate underneath a tree and you're off label, you have more problems than underneath the labeled rate, but also species susceptibility. Different tree species have different susceptibility ratings for different herbicides. And then also something that a lot of people don't think about is the cumulative effect from repetitive herbicide applications. So you get a little drift one year, from the bean field next door, not a big deal. You get a little more drift the next year, it becomes a bigger deal. You get a little more drift the year after that, and so forth and so on. You start having that cumulative effect, and you see mortality start to encroach in in whatever either your forest stand or on your trees in your yard. So this particular class of herbicides, you'll see that cupping I'm talking about. You'll see the curling over of a lot of the foliage. Depending on the level of exposure, you'll have that chlorotic appearance, so yellowing of leaves, if you look there in the lower right-hand corner, to the heavier applications or more off-target impact, where that chlorosis will pick up and you'll get total yellowing, you'll turn into necrosis where your leaves actually turn brown, and you will actually blow the terminal buds out of a lot of these too. And I'll show you a photo in a second of that, where you get to a certain exposure level and you actually start killing the woody tissue, not just the foliage. Translocation takes a lot of those other tissues out. Aminopyralid, clopyralid, triclopyr, and quinclorac, used for a variety of different things. Aminopyralid and triclopyr are going to be the more damaging of those, depending on when they're applied, and a lot of things that we don't have time to talk about. Early on, you'll get that chlorotic appearance. If you'll see on the lower right-hand corner there, you'll get that chlorotic appearance where you get the interveinal thing going on. You still have the green veins, but you'll get that yellowing in between the veins. The higher your rate, the more of the necrosis and mortality you expect to see. If you'll look at that photo on the top, that is basically a quart of triclopyr. Now we're trying to kill them. That's a quart of triclopyr in that particular case over several tens of thousands of sweet gum to the acre in that particular photo. Works really, really well in the right setting. Lawn settings, you'd be very, very careful when you're getting in and around trees. Now, triclopyr is foliar only, so on the ground it's not a big deal, but you get into some of the ester formulations, you get volatilization, you get into certain temperatures, or you get into inversions, or you get into windy conditions and running really mist blowing type tips on your spray rigs, you can run into issues like that. Clopyralid and quinclorac, same family, they're not going to typically be as damaging. You can bump those rates up to a point where you get more than just sclerosis, but typically you're not going to see the damage out of those. So you're starting to you'll still get the cupping, but you're not getting the necrosis. You're not getting the mortality out of those herbicides you do out of some of the others. You're starting to be able to pull some of the herbicides off the table when it comes down to trying to figure out what actually did the damage. The other thing I want to mention there is if you do have leguminous species, those first three will absolutely nuke them. With clopyralid, which you can spray right over the top of a lot of hardwoods, if you spray over the top of a legume species, you're going to have issues. It's going to kill that tree. Dicamba and picloram, still in the same family of herbicides, much more damaging. Dicamba, typically it was going to be something used in ag. You'll also see it used in turf. Mainly a drift issue where we saw problems with it. I saw one that, without going into a lot of the detail, basically I was about 10 miles from the point of origin. It actually crossed the Batcher ground in Arkansas, the river, and then the Batcher ground in Mississippi, and then we were standing 3 or 4 miles outside the levee on the Mississippi side, and we were picking up a lot of dicamba symptomology on yard trees, actually over in a county in the Delta. Not a big problem now because the EPA pulled that product off the list. So there's still a lot of it out there. You can use what you, to a certain point in time, you can use what you already had purchased. But my understanding of it is the several different formulations that existed, those are gone with the exception of one that was coming through the registration process when the EPA made that ruling. So don't look for a lot of dicamba issues. Picloram. Picloram was a Tordon product in forestry. You'll see it used a lot in range as gray zone P plus D, Picloram plus 2,4-D. You'll also see it used a fair amount in right-of-way work. It's off-label in lawns, but we all know where that goes. People will put it out there. One of the arguments that I've heard against it is, well, we spray it all the time on pastures. We've never had any issue. Good for you, I'm glad. But if you'll go on and you'll look at the EPA write-up on Picloram, there's a direct quote. Highly soluble in water, resistant to biotic and abiotic degradation. It's mobile under field condition. It's stable to hydrolysis. It's stable to anaerobic degradation, and it degrades very slowly with half-lives ranging from basically 6 months to a year and a half. It will move. That's the reason we don't see a lot of it used in forestry. Was you put it out there, it moved off-site, and you nuked your neighbor's trees. When you get into the hardwood world, things are very, very, very susceptible. Picloram is really interesting. I don't have an early picture of picloram. If you put picloram out and you at least through root exposure, picloram on the ground, it won't take out the weed. It will take out some of the weeds. Let me rephrase that. It won't take out grasses. So what you'll get is you may have some broadleaf weeds that are damaged on the ground. roots will uptake it, and it'll translocate up into the canopy in the tree. And what you start seeing are single leaves that'll pop. I mean, everything will be green except for a leaf here and a leaf there that's totally brown, totally necrotic. And then as time progresses, you get more and more and more of those leaves, and things just drop away. Very, very, very nasty herbicide around hardwood trees, especially. The next group that I want to talk about, the symptomology of, are going to be root growth inhibitors. The only one I'm intimately familiar with is pendulum. Several of those out there, but they're very rarely a problem from a tree standpoint, from damage to trees. When it does pop up, it's going to be the result of drift. It's going to be something that drifted in. It's not going to be soil absorption. What'll happen is you'll get swollen twigs, brittle twigs. The leaf petioles will swell up, kind of like the base of this little pine seedling you see here, and then new leaves that form will be deformed and resemble those of that cupping effect that you saw in the growth regulators in the last group of trees. That cup look. The next herbicide class that you see are the ACCase herbicides, lipid synthesis inhibitors. You'll hear these called Group A herbicides. You'll hear them called graminicides or grass herbicides. That's what they're going to take out. Very rarely you see any problem with the graminicides and tree damage. When you do, it's going to be from drift, and it's not going to be the herbicide that actually does the damage, except for one thing I'm going to mention here in a second. It's going to be the fact that, and Select is the one I'm the most familiar with. It's going to be either the MSO or the crop oil that they recommend as a surfactant. So you basically burn the leaves. So if you do run into issues with one of those herbicides, you can look right down here on the bottom. Those two arrows, it doesn't show up that well in this presentation, but those are actually little pine trees. You spray right over the top, it doesn't do anything to them. If you do run into a situation where you have some damage from the graminicides, odds are it's not gonna kill the tree. You'll get that chlorosis, slight yellowing going on, and nothing really winds up happening to the trees from a mortality standpoint. With the exception of junipers and azaleas, for some reason, and I'm not exactly sure what it is, but for some reason, juniper species, so the little ground running junipers that you'll see used in landscaping, and azaleas are supposedly relatively sensitive to that particular class of herbicides. I actually put in a study the other day to look at that with eastern red cedar. So in a few months, hopefully I can say, yeah, it works, or no, it doesn't. So we're going to see. But apparently those two are relatively sensitive to those. And outside of that, you really don't have any issues with graminicides. Interveinal chlorosis, wilting, necrosis, and mortality when you get into situations where you have a lot of exposure. So if you spray directly over the top of those two species, or species groups, I guess I should say, you can run into some issues with those. Outside of that, it's really not an issue. Now we're talking about the cellulose biosynthesis inhibitors. There's only one that we really see much of, and we use a little bit of this in forestry too, but that's indaziflam in the form of a spectacle. Basically what happens there is you get cellular division limits in root tips, in developing root tips. Really uncommon to have an issue with it. We can spray right over the top of a lot of different tree species and not have an issue. But in some cases where you get heavy drift concentrations of those particular class of herbicides, you can get some of the chlorosis, the puckering, purpling of foliage. You'll see the photo on the bottom right-hand corner there. You get a kind of a purplish tint, and you get those. They look like blisters. Those puckers. It's kind of unique in the herbicide world. Distortion that does kind of look like epinasty, or that cupping effect that we saw in the growth regulators. You'll get some of the stem girdling or the swelling right at the soil line in seedlings. So it has kind of a slate of different symptoms that can come along with it. Just very rare that it's going to be an issue in forestry. Now you move over into the ALS inhibitors, so acetolactate synthase inhibitors. Basically, it limits enzyme production in amino acid synthesis. These are also called the branch chain amino acid synthesis inhibitors, if you're interested in that. You got a lot of different herbicides. A lot of what we use in forestry, some of the heavier duty herbicides are going to fall into that group. And then, of course, some of the things like MSM turf, and then sedge hammers, certainty, the sedge control type long setting herbicides. Depending on the herbicide, most of these are going to be foliar or soil active. So with imazapyr, for instance, a lot of people think that it's one or the other. It's not. It's actually like 60-40 or 70-30, something like that. You actually get a lot of it that'll go through the foliage, but it does have some soil activity associated with it too. They're kind of interesting in the way they work. They translocate to active growth. So whether you spray it on the leaves and it translocates, or whether it's root absorbed, a lot of that herbicide goes to the sites of active growth, turns them yellow, they go chlorotic, and then they die at that point. And then new growth after that comes in, it's distorted, and it'll die back, it'll turn yellow, things like that. When we start talking about low-level exposure type situations, you get things going on like you see here in the photo on the right. Now, all these photos in this series are going to be for imazapyr. This particular one, you'll see that chlorotic appearance, and you'll see some necrosis around the leaf margins that comes in, but it's not the leaf margin as a whole. It starts kind of encroaching on the leaf margin from one point, and then you'll also have some spotting, things like that. You'll get this kind of thing going on where you have that purpling or reddening of the veins. This happens to be strawberry, but you get the same effect on tree species. As you get into older foliage, so we're not talking necessarily the new foliage, you have the actively growing foliage, you get into a situation where you're really truly getting a spray over, not just a low-level drift, a higher exposure, but still not in the realm of mortality typically. You'll see wrinkling, the leaves will actually wrinkle up or crinkle up, and you will get some leaf damage, but typically not going to be a mortal type damage. And then, of course, that newer foliage, you'll still have that yellow appearance and potentially some twig dieback. As those exposure levels increase, whether it's from foliar or whether it's from root, either one, you'll get dieback. You'll see those stems start to die back. You'll get witch's broom. You'll get that dying back of the twigs. And you'll get those guy I used to work with a lot called it weirding out of the buds, the leaf buds and things post application. This is usually something that happens further down the road. When a tree looks like that, it's in trouble. I'm not saying it won't grow out of it, but it's definitely in trouble. You'll get shortened internodes. This happens to be Chinese elm. And you'll see the healthy one on the left, the unhealthy one that's been exposed to imazapyr on the right. You see those shortened internodes. You also see the witch's broom from the around the base of the petioles of those leaves, and you'll also see some necrosis and even a little bit of chlorosis in this particular situation. At that point, when you get to exposure levels that high, they may pull out of it, but it's definitely a more serious situation than a light drift when you have trees that look like that. I like to use one of Andy Ezel's the things he used to say there about especially imazapyr exposure. He'd say a lot of times, and he's talking primarily about mid-story injection, but a lot of times, what'll happen is you inject it and you won't see anything quick. These are slow acting. It takes a while for it to take effect. What happens is he'd like to say, you hit it in the winter, it goes to sleep, and it just never wakes back up. And you'll see that a lot with this particular class of herbicides. A lot of them are going to be applied early in the year, but a lot of them are going to be applied late in the year. And you'll see just a gradual deadening that takes a lot of time, or they'll actually go through their processes in the winter. Leaf fall occurs, and they just never wake back up. Kind of an interesting scenario in that particular case. We get over into the photosynthesis inhibitors. These are really interesting. We don't use really any of these in forestry, but they're really, really interesting in the way they work. They're post-emergent, they're non-selective, and they're broad spectrum. They're called contact herbicides for a reason. Basically, you get it on that tree, they don't really translocate, or you get on that leaf or foliage or vegetation period. It doesn't translocate. It basically kills it right there. And you'll see it sometimes where you'll have half of a leaf dead. It's almost like a line. If it was shielded by another leaf, half of that leaf's dead, and you don't get any deadening past it. It's just necrotic, and it moves on. A lot of that used in ag. The one I'm most familiar with is going to be paraquat or gramoxone. You'll also see diquat used some, and atrazine of corn fame. And they're really interesting in that they do disrupt photosynthesis, but they actually block electron diversion. From instead of entering and going through chlorophyll and into photosynthesis, it'll actually divert them. It'll create free-ranging radicals inside the cell, like one that pops into my mind is hydrogen peroxide, and it will actually disintegrate that cell membrane from the inside. They're incredibly fast acting, is the term, contact herbicide, really, really, really fast acting herbicide. So you don't get that translocation, which is good in the case of drift. You don't have a chance for it to really move throughout those trees. Light drift, light contact, you get this kind of thing going where you have the little spots, and you can see those spots on different leaves. You'll see this a lot around ag fields early in the spring, or I think May, June, when this type of symptomology is there by the time most people notice it. But this is from burn down, when they're burning off that winter weeds that basically grow in a lot of those fields. As it progresses, you start picking up some of the heavier drift. You can get into mortality and things like that. And a lot of that does start from leaf margins, and it goes inward in towards the midrib of the leaf. In pines, and this is one that is incredibly sensitive. Pine species as a whole are incredibly sensitive to this class of herbicides. There's a reason, and it's not just because of site differences that you don't see a lot of pine in the Mississippi Delta. With the burn down herbicides that are used in the spring, it doesn't take a lot to actually take out most pine species. This particular slide photo on the left-hand side here, you'll see on the right-hand side of that tree, you've got kind of a browning effect. That's 4 miles away from paraquat that was sprayed on a windy day. That's Virginia pine. Don't get me started on why the guy planted Virginia pine. He's got a little Christmas tree plantation, but that's what kind of damage comes from paraquat in and around pine trees. That's a very light herbicide application. Like I said, drift. This is what happens, and sorry, I don't have a better photo than that. I just didn't have one. That's the best I could come up with. That's the kind of damage you get with pines and around paraquat. They're incredibly sensitive. They can't take it. They drop out. So that moves us on forward into another type of amino acid inhibitor. These are aromatic amino acid inhibitors, slightly different attachment point for the herbicides. The one that's the most familiar that most people know about here is going to be glyphosate. There are about 3.7 kajillion different glyphosate products out there. Used everything from turf to right-of-way work and anything in between. Some have aquatic labels, some have forestry labels, some have turf labels. I mean, there's a ton of different things out there. They're foliar active only. What'll happen with this particular class of herbicides is typically it's going to be chlorotic type of symptomology early on. So I mean, even in this witch's broom, you see some of that yellowing. It's not really a good green, if you want to think of it that way. You'll get that chlorotic appearance, and it'll turn necrotic and it'll die. If the application is done at the right time of year, under the right weather conditions and things like that. But where it gets really interesting with glyphosate is you get if you have a late season application and you get translocation to the roots, right? The plants are shutting down, they're pulling the reserves back into the root systems. You get that translocation back, through the structure down into the root system, and then the next year when the tree wakes up and starts growing, it pushes basically glyphosate back up through the vascular system and out to the points of new growth. And that's when you get a lot of really weird symptomology that doesn't necessarily look like glyphosate symptomology, like you see right here with witch's broom. You'll get a lot of the growth regulator actually symptomology, where you see that cupping, you get chlorosis, the epinastic type look. And then you also can pick up stem splitting and things like that. And if the rate was high enough the preceding fall, you can have some mortality that was just delayed from the last year. And this is the one that gets a lot of people, because they go, well, I haven't used glyphosate since last year. You didn't, and it's foliar active only. They're right, and that's what's going to get thrown back at you. But it's still the effects from it actually translocating down to the roots in the year before that carry over. So last really class, if you want to look at it that way, of herbicides that I want to touch on is soil sterilants. Now, anything with just a few exceptions can be a soil sterilant if it's applied at a high enough rate. I mean, if you put enough of something on the ground, it will get to a point where it's probably going to sterilize from a plant standpoint, sterilize that soil. However, labeled products that are labeled as such, there's only one that you're going to find commonly. Now, again, there are other things out there, but the only one that you're going to find talked about or marketed much is going to be tebuthyron or spike. It's a photosynthesis inhibitor, just like gramoxone and the ones we talked about earlier. It just has a lot more intense result when the trees are actually hit with it. What you'll get is something like this. Everybody probably remembers the Auburn Tumors corner trees, where the Alabama fan came in after a game and spiked the soil around the oaks there on the Auburn campus. You had before, after, they tried doing a lot of things to save those trees. Did not work. Trees slowly died, and now they are gone. They've been cut down. Again, it works a lot like what is a photosynthesis inhibitor. You get the same type of symptomology right there. It just happens to be soil absorbed, soil applied as a sterilant. It will be there for a while before those soils are actually viable for plant life again. The other one that pops up at you is salt, good old table salt. You will see that in a lot of these homemade weed killer recipes that you can find online. They don't really work that well. They also, one of the recommendations you see with those, well, if it didn't work, then you spray a little more. And if that didn't work, you spray a little more. If that doesn't work, you spray a little more. And eventually you do hit a sterilant level of salt in the soil. And that works, it's without getting into the chemistry of it. Basically, nutrient and water absorption is impacted in that it displaces and nutrients, clogs the soil, and basically it locks up those nutrients in the soil. If you get enough of it in there, it actually does get translocated by the tree. Chloride's transported to the leaves, and you get interference with photosynthesis by limitations on chlorophyll and things like that. Also does the same thing you'll see, and primarily going to happen up north. You'll see the same thing when it's sprayed on roadsides or sprayed on sidewalks, that kind of thing. I have actually seen it 2 times in Mississippi where that's really dug and started looking at it. It wound up being salt damage, and both of those were from saltwater swimming pools, believe it or not, with drip, where they were dripping on the edge, and enough salt got in the soil that started killing some trees in the yard. So it can happen here, it's just not real common. Once you get into that sterilant level type impact, there's some other things to look at with salt exposure. With pines, you'll see the needles browning from the tip and moving to the base. When you get into the broadleaf species, you'll see that same type of necrotic response. Of course, it goes from the leaf margin inwards and things like that. A lot of them just won't, they almost act like imazapyr products, like we talked about a while ago, where they just go to sleep and they don't come back. They don't reemerge in the spring. You'll get things like dieback, witch's broom, and the list goes on and on. The other thing that you can look for out there is that one-sided symptomology, where you see one side of the tree more heavily impacted. Typically, it's going to be on the side where the salt was applied, but you'll see one side of it that's more heavily impacted than the other side. Once you get down into the point where you're trying to actually, you have all this knowledge in your head about what different herbicides do, and you're trying to actually diagnose which herbicide was used and potentially some type of corrective action that you can take, there's a few things to think about there. It is a difficult process, right? There are so many things that are similar to different types of herbicide symptomology in nature that's not funny. On the biotic side, I mean, fungal issues can create a lot of the same problem, or appear to be the same problems that you're looking at. Drought stress will do things like that. I mean, there's little fine things that you can look at, but they appear to the average person to be very, very similar. You also have the fact that a lot of herbicides have very similar symptomology. And then there is that chemical side, sent into the state chem lab, and there's a cost associated with it, but there's also the fact that it can't be too long after the application that you collect that sample and send it in. It has to be detectable. All of these herbicides have half-lives. Some of them are very short, some of them are a lot longer, but they do have to have a detectable level once it makes it to the lab. So you're running on a stopwatch. You do have a timer going, and you have to put a little effort into getting out there quick enough, if at all possible, to collect that sample and send it in. Basically, if you're going to do this from an optical standpoint and actually go out and look at it in the field, you have to know a lot about the effects of the different herbicides on a lot of different species. Now in ag, if anybody's ever taken herbicide technology at Mississippi State at least, this is the way they do that. They plant 6, 7, 8 different species of crops and weeds in trays. They spray over it with a certain type of herbicide, and they decide, or they observe what this herbicide does on this species, this species, this species, this species, and look at that as opposed to what it's supposed to do on the different species. And when you have that many things together, you're able to actually, like I said, you're able to diagnose, you're able to start weeding out different things that it can't be and come up with an idea of what particular herbicide you're looking at. Harder to do in forestry, right? We don't necessarily have a bunch of different species that have that type of knowledge, symptomological knowledge behind them. To do, go through that process, you do have to know a lot about the mode of action, how it actually works, how long it stays in the soil, how fast it occurs, and then you also need to pay a lot of attention to adjacent vegetation, what's going on with the grass underneath the tree, the broadleaf at the side of the yard. If it's a single species, you're seeing effects on a single species, fair chance that it could be something that's not herbicide. It could be a fungal issue, it could be an insect, something like that that's working that particular tree over. But if you see it on that tree and you see it on other trees, you see it on different categories of vegetation, grasses and trees, or broadleaves and grasses, or something like that, odds are it's probably some form of herbicide. You also can you can follow drift pretty easily, direction that things came in either through the air or through water in the case of some herbicides, where they'll flow onto a site. Weather conditions on site, a lot of different things that play into it. You really have to know your potatoes on that particular one. So when we actually get down into treatment possibilities and looking at how to actually not only diagnose the herbicide that was used, but look at possibilities for hopefully keeping the tree alive or pruning things out of it that are dead and things like that. There's a lot of things that play in. Herbicide used is very, very important, right? That's the one that most people think of. But species, in this particular case, we're looking at 2,4-D on an oak. 2,4-D on an oak reacts totally differently than 2,4-D on, this case, longleaf pine. There's a lot of differences in the way any single herbicide will work on any grouping of species. Also, the rate, the more herbicide that's put on that tree, obviously you stand a greater potential for having more damage. And then timing. Timing is pretty important too. Effects that you're looking at on a tree can lead you into a decision on whether it is or isn't a specific herbicide in a particular class of herbicides. In this case, that's a sweet gum. I know for a fact that wasn't the glyphosate that they claimed they put out in February. Glyphosate is foliar active only. It does not do that to a tree unless it has leaves on it. That's drift. If you'll notice, the field is actually behind that tree, and it came from the other side. That tells you a lot, and I'm not going to get into where that was or the specifics of what was behind it, but it turned out the guy that did the application was just flat out lying about what he put out there, and he did wind up having to pay some people. But there's a lot of things that can be picked up pretty quickly when you start really being a detective and looking at the symptomology that's on the ground. Healthy plants that are exposed, typically, so long as the levels of herbicide don't get above a certain point, not as big of an issue as something that's stressed. You get into situations where a tree's in a drought situation, or they have compacted the roots, or on and on and on. It's a lot easier for that tree to drop out on you than a healthy tree. A lot of times, it really just boils down from a treatment possibility. You gotta let it do what it's going to do. Only time is going to be able to tell you what's going to happen. That may be weeks. That may take a year and a half, something like that. I like to throw that photo up when I talk about that particular aspect of treatment possibilities. The guy that did this to this tree is actually a forester. He should have known better than this. He had been doing mid-story injection with imazapyr, had a couple of bottles, mixed bottles, turn over in the back of his truck, leak out, and he just pulled, backed the truck around, dropped the tailgate, and washed it out underneath his water oak. And then I get the call about 6 months later, the next spring, what's going on? What do I do? How do I fix this? Is it going to kill it? Look at that tree and you think, yeah, that tree is probably dead. And I told him, I said, that's probably going to drop out on you. Believe it or not, I mean, you can still see it in the green that you see in the upper portion of the canopy there. That's actually mistletoe. If you'll look around the bottom, you see a few leaves that are sticking around. Believe it or not, the next year that tree probably had 40–50% foliage, and the year after that, it was right back. They can take a licking and keep on ticking, but I called that tree dead. I would have thought it was dead. But again, unless there's an immediate reason to cut down somebody's yard tree, give it a little bit of time. Sometimes they'll pull through when you really don't expect for them to. If you know that you've exposed a tree to some form of a foliar active herbicide, if you immediately wash those leaves, you may reduce the damage. If you wait until that herbicide is absorbed and translocated, or especially once the tree is symptomatic, too late. There's nothing you can do about it. If you get into a soil applied herbicide, some of the pre-emergents, things like that, there's not a lot you can do. Don't water it. That's one of the first things. That's what they did with the trees at Auburn. One of the first things that they do is they run out and they try to flush it through the soil. If you're in drought conditions, you may not. The half-life may come into effect, especially on some of the shorter half-life herbicides that are out there. Those herbicides may degrade before you get enough of it into the soil to become problematic. And they may be metabolized by the herbaceous vegetation that's on the ground, and by the time you actually get enough rain on the ground to push that herbicide in, it may not be as big of an issue as it was before. That said, don't forget, even non-problematic herbicides, quote unquote, can be problematic once they get to a certain level. The other most common applied treatment, from a ameliorative standpoint, is going to be something like activated charcoal. Activated charcoal, and I'll show you a couple of slides here of the procedure. Activated charcoal, top three, basically disc it in or till it in to the top 3 to 6 inches of soil, somewhere in the rate of 150 to 200 times the weight of the active ingredient in whatever herbicide that you put out there on the ground. Gives you a shot. It's not always going to work, but it gives you a shot. But again, you need to do that right now. You don't need to wait 6 months down the road, and once you start seeing the symptoms in the tree, odds are it's probably too late, just the way it works. Activated charcoal is kind of neat stuff. It's not just charcoal briquettes that you go buy at Walmart. I mean, there's a process. It's heated or it's treated chemically and to do some things. The people I stole this slide from, the series of photos from, basically just mixed it up in a bucket, poured it straight into a solo backpack sprayer. I know, and they even commented on in the little blog that I stole this from about how hard it was to get it to go through the sprayer on that, the tips on that sprayer, but they got it to work. They sprayed over the top of the ground. So basically you're getting on top of the ground, they let it dry for about an hour, and they came back and they tilled it in. That's the way it works. Another possibility that's out there that you'll hear talked about some is soil removal. So everybody knows what's going to happen if you go out and you pull the top 6 inches of the soil off out there, not just from a root damage standpoint, from a cost standpoint, but also from a expense standpoint, and that you've got to go back and you've got to put new topsoil down, you've got to resod it, things like that. And it's still going to be something that you have to do immediately. By the time it translocates or it moves through that soil, I guess I should say in this case, you start running into it's too late. There's also slit trenching with barriers. You'll see that done some. That's really typically huge spills. Somebody turned over a drum of herbicide or something like that, and it spilled into the soil, and you'll see some basically plastic barriers put into slit trenches with the expectation that it'll slow or impede the movement of that herbicide through the soil. Also very cost inefficient, but it may or may not be all you have to work with. Donna mentioned these two pubs along with a couple of other publications. I did want to point out MSU Extension Pub 3273. Everything I talked about today is inside that particular publication. That was actually a lot larger pub than I intended when I first started on it. Everything I've said here is detailed with much more depth in that particular publication. And then the publication on the right, it is one that I actually wrote earlier this year. It's very, very short. It's really meant as an information sheet. But what it'll do is, I think I got 16 different herbicides on the left-hand side of that table, and then 20, 22, something like that, different genera of trees that go along the top of that particular table, along with susceptibility of those different species to the different herbicide groups. And it gives you an idea of what to look for. And once you start trying to whittle down that list of herbicides, and you can look down that, you can look down that list and see, well, this one's not supposed to have negative impacts where this one does. And it gives you another little tool that you can use to, like I said, to start whittling that list down and coming up with an idea of what you may or may not be looking at.